Hi everyone, welcome to the first lesson of our new topic here, which is topic 4.1 time series analysis. So by looking at the numbering here, you should realize that we are moving into unit 4 and then the first topic. So which means by this time we already completed like half of our syllabus, which under unit 3. So if you can recall, then 3.1 we talk about bivariate data analysis. Then we have your categorical data and numerical data. Then after that, for 3.2, we talk about growth and decay in sequence. Then 3.3, which we just finished on Tuesday, which we discussed about graphs and networks. So starting from this lesson, we are moving into Unit 4. So similarly, we are going to have three topics as well under Unit 4, which is 4.1, 4.2, and also 4.3. And the content of the syllabus are arranged in such a way that 3.1 and 4.1, they are related to each other. Same things go for the second topic and also the third topic. So it means that what are we going to learn today under time series analysis is actually build on your foundation or build on your prior knowledge on the topic of 3.1. Okay, so you can also take this time to do some revision of your topic 3.1 before you move into this lesson, especially for the part for numerical data. But no worries about that. The skill and the knowledge that you need will be a little bit different, but the idea that you are using is basically similar because time series analysis is basically one type of bivariate data analysis as well. Okay, so let's try to look at today's learning outcome. So we are going to look at how to describe and interpret the patterns in time series data. So in bivariate data analysis, we have scatter plot. So in time series analysis, we have time series plot. Okay, so two things that you will need to know today. The first one is how to construct a time series plot. How does that look like? What should you put in the horizontal axis or the vertical axis? Okay, then the second one is, so this is the first one, how to construct the plot, the graph. Then the second one is how to describe the time series plot. So which means that by observing it, for example, in scatter plot, you have, the strength, the direction, and also the form, right? So for time series plot, we are going to look at different things such as what is the trend, okay? What is the seasonality, and also what if, let's say, if they have like irregular fluctuations. Okay, then for outliers, you already know this, so basically I'm going to cover these three parts today. All right, so let's start our lesson today. All right, so we are going to start from what is the definition of time series data. So basically, what is time series data? All right, so time series data is one type of bivariate data. So I hope that you still remember what is that meant by this term, meaning data with two variables. So we are talking about numerical basically. So time series data is one type of bivariate data in which the explanatory variable is time. So in the other words, which mean that it is a set of values of variable, which the variable is going to be treated as your response variable in this set of data. So it's normally recorded at a regular interval over a period of time, such as it can be hours, it can be a weekly frequency, or it can be monthly or annually. Okay, so why are we doing this time series data? So the objective of the time series is to help us to investigate how some variable changes with time. Okay, later I'm going to give you some of the example, then you'll understand it better. So it's actually quite simple. Okay, so it helps us to understand the past. So by observing what happened in the past, then what we try to do is we try to predict and also use the result to try to plan for the future. Okay, so let me try to give you a simple example here. So for example, if we talk about daily temperature, so which means that our explanatory variable here will be time, and then the response variable here will be the temperature for each day. So when I try to put into the data, right, then I'll be able to see how temperature changes with time. Am I right? So you can realize that no matter which variable that you are investigating, So at the end, your time will always be the explanatory variable because time is the one that you can't change, right? So everything change according to time. So time will always be your explanatory variable, and the variable that you want to investigate will be your response variable. So for example, time is the EV, then temperature is the RV in this case. Okay, so other than temperature, maybe you can try to talk about, in Malaysia, we have weekly petrol price as well. Okay, so by putting in the petrol price in the time series, then we'll be able to see what is the pattern, or we can actually use what we have to try to predict what is going to happen in future if let's say there's a specific pattern. Okay, so same thing, you see the week, first week, second week, third week will be your EV, then after that the petrol price will be the RV, which changes accordingly to the week. Okay, then after that, we can also use it. For example, if let's say I try to work in a store, then maybe I can try to find out what is the monthly sales as well, right? So maybe monthly sales of a certain brand of shoes. Okay, then I can try to use it to find out what is the monthly sales, and if let's say I want to observe what is the pattern, then I'll try to do analysis from that. Okay, then the last one, maybe we can talk about like annually, so maybe an annual profit of a company. Yeah, so these are all the example that we can use time series data to help us to observe, to help us to do the analysis. All right, so yeah, I hope that you can get the idea now. It's actually quite straightforward. Okay, so for time series data, we are using this plot which named as time series plot to help us to display our data graphically. Okay, so the graph of a time series with time plotted at the, so just now we talked about time is a explanatory variable, right? So that's why explanatory variable will be always plotted on the horizontal axis. Okay, then of course the variable that you are going to investigate is supposed to be your RV lah. So we can try to write down here. So your horizontal axis will always be the time. Then the vertical axis, which is going to be your response variable here. So which is the variable that you want to investigate. Okay, so something different between time series plot and scatter plot is that time series plot is a line graph. So which each point is joined to the next one by a straight line. Okay, so the idea of plotting it is actually the same. So for example, we know for numerical, we are going to find out, I mean, you have coordinate, then after that, maybe you try to plot it, am I right? But for scatter plot, normally we just leave our answer, I mean, you just leave your scatter plot as if in a dot points like that. Okay, but for time series plot, because we are going to deal with like seasonal variation, so for us to observe the pattern or the trend in a much more easier way, we are going to connect all the dots here together by using straight line. So which means that after we try to plot down all the data points, we are going to connect them. Okay, so basically just like that. Alright, so later we are going to do an example of time series plot. Then hopefully from there you'll be able to get the idea of how it's that look like. Then the same thing, I'll also teach you how to create the graph from your calculator as well. Okay, so let's flip to the last page of your handout. So yeah, no worries, we'll come back to the notes part later. So right, we are going to create one time series plot before we move on to the interpretation. Okay, so during 2014, the owner of a particular tourist attraction decided to use the data regarding the number of visitors the center has had in the recent year. So to try to identify what is the trend, then maybe to find out what is the visitor figures for the future. So this owner have access to like the visitor total for in like first 4 months, second 4 months, and also the last 4 months during a year. So he has these different data here. So we are going to use this to create a time series plot. All right, so let's start to do that. So the first thing that we need to do is to draw the axis for the horizontal and also for our vertical first. Okay, so now let's put a scale. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have 10 data here. So I think we can try to use like 5 small boxes for one. All right, so the first one we have January to April for the year 2011. So January to April for 2011. Okay, so we are going to label every one of it. So from May until August 2011. All right, so I'm going to fast forward this process. All right, so same thing for the x-axis here is the time. All right, so then after that, we are going to do for our y-axis here, so which is going to be the visitor in thousand. So the maximum number that we have here is 69, so we can try to use 5 boxes for 10. So we have 10, 20, 30, 40, 50, 60, and 70. Okay, so now we can try to plot all our data here. So the first one we have 45, so it's the first dot here. So 45 is in the middle. All right, then after that 26, so 26. Okay, then the next one 34, 52, 37, then we have 42, 64, 41, 50, and also 69. All right, so make sure that you are plotting everything correctly. Okay, so now we are going to link all the data points together by using straight line. So you should be using your ruler. So basically just connect them together from period to another period. So which means you are going to do this. All right, remember using ruler, so it should be a straight line. All right, so just connect all the data points together. Oops, sorry. Okay, so I hope that you can get this pattern of the graph. So later, after we learn how to interpret the graph, then we'll come back to this example again. All right, so now let's try to learn how to use our calculator to construct this. Okay, I mean, sometimes if let's say the question didn't need you to construct everything like physically on a paper, you might need to construct it in your graph so that you can try to look at the pattern. Okay, so you will need to know how to do this in your calculator as well. It's basically the same thing like how you create the scatter plot, but then just to add in the line between the data points. Okay, so let's get ready our calculator. Okay, so similar like bivariate data. So if we were to input all the data that we have, so we need to add list and spreadsheet. Okay, so same thing, let's try to assign our variable here. So we have period of time, so let's just put T maybe, then visitor we can put it as V. Okay, so you realize that in our data here, right, what we have for the period of time is January to April, then May to August, September to December. But you need to know that in our calculator, it can't actually work like our human's brain that we understand is like the first month to the fourth month, then after that the fifth month to the eighth month, and so on. So that's why in our calculator, what we need to do is just assign it with like number. So we try to treat it like numerical number. So this is my first period, which consists of January to April for 2011. Okay, then after that, the visitor number here is 45. All right. After that, when we move on, so this is our second period, which represent May to August for the year of 2011. So tap, so the 26,000 visitor. Then when we move on, same thing. This is our third period here. So that's why 34. Okay. So we are continue to input all this data into our calculator. So fourth period, 52. Then the fifth period, we have 37. But of course, if you want to put everything like this also can. So I think this is easier because you can just enter everything. So 6, then enter 7, 8. So we have 10 data here. Okay. Then now let's try to input the number of visitors. So after 37, we have 42, 64, and then continue with 41. Okay, 50, and the next one is 69. So make sure you check again after you put in all your details. So the first 45, 26, 34, 52, 37, 42, 64, 41, 50, 69. Okay, so everything is correct. So now let's try to create the scatter plot first. Okay, so how to do that? So you need to insert another page first. So control page, so add data and statistic is exactly the same thing like how you create a scatter graph. Okay, so now after you click in this, then you'll be able to see this. So we need to click to add in our variable, right? So same thing, move your cursor, or you can just press tab in your calculator. After that, the calculator will straight away show you that you can add in your variable. So in this case, we know that our time should be what is the month, so which means the period of time here, right? So it's going to be our P. Then after that, for the variable for Y is going to be number of visitor, which we assign as V. Okay, so after you got this, you realize that you roughly can see the pattern, which is like what we have for the data points before we connect them together. But if let's say we want to add in a line, then how can we do that? Okay, so there are two ways to do that. So the first one is press menu. Okay, then you realize that there's plot type. So you just, when you try to go into this menu, right, you'll realize that you have only one option here, which is the XY line plot. Okay, so you can straight away press menu 1-6, then you should be able to get the line. All right, so let me try to remove this again. So the second thing that you can try to do is you go to menu, and then instead of go to plot type, you go to plot properties. So under plot properties, then the same thing, the first one, connect data points. So after you press 1, you press enter, then you'll be able to get the exactly same thing as well. So you'll be able to compare the graph that we draw in on the graph paper and also the graph that you have in your calculator. So basically, they show you the same pattern, they show you the same variation here. Okay, so if let's say you want to remove the graph, then you just menu, then plot properties, then you just hide the connecting lines. Okay, just like that. Alright, so I hope that you get how your calculator works to create a time series plot. And now we are moving into the next part of the lesson, which we talk about how to interpret the time series plot that we have. Alright, so in this part, we are going to look at interpretation of time series data. So basically, after you create a time series plot from the time series data that you have, you are going to observe it. You are going to observe how is the movement or how is the fluctuation of the data points. Then from that, we try to observe their trend, their seasonality, and also whether they are regular or irregular fluctuation. Okay, so the first two one will be more important because this is basically the type of data that we are going to do analysis. So for irregular fluctuation, there's no analysis that we can do for our level of syllabus here. So you just need to know what is the shape of the graph that give you irregular fluctuation, that's it. So basically the data that we are going to do further analysis will be the seasonal data. Okay, so a time series can have one or more than the following components. So let's try to look at the first one, which is the trend. Okay, so trend, or in a simpler words, we can call it as long-term direction, but then in a much more accurate mathematical term is known as trend. So trend is a term that we use to describe the general direction of a time series over a long period of time. So remember, the keyword here is a direction over a long period of time. Okay, why is this important? Because when we try to look at this data, right, okay, you can see that if we are trying to observe it in terms of a short term, you will realize that there's actually increase, decrease, increase, decrease, and increase. So when we talk about the trend, we are talking about general direction in a long term. So although they are increase and decrease within the data points, but when you try to look at the general trend here, it's actually increasing. So this is what is that meant by the trend. So you can see that as time goes on, your response variable will be increasing, right? I mean, when I try to compare the initial point here and last point here, obviously it's like increasing. So that's why in this case, we are calling this as an increasing trend. Okay, I think it's quite simple. Okay, then after that, the second one here, same thing. If you were to observe in short term, then you'll realize that there's up and down. Okay, but then if let's say we try to look at it as a long term, then which means that we try to look at it generally, then you'll realize that first point and the last point is obviously like a decreasing one. So in this one, which means that as the time goes on, then your response variable, the variable that you are investigating, is actually decreasing. So that's why what you have here is a decreasing trend. Okay, so I think first one is actually quite direct. It's quite simple. So remember, when a question asks you to describe the trend, basically it's either increasing or decreasing by looking at it as a long term. Okay, second one, seasonal variation. Okay, so when you look at this word seasonal, basically comes from season. So we are going to talk about the variation of the data depends on the season. Okay, I mean the season isn't referred to only like the summer, winter, spring, the kind of season, which means we are going to talk about a kind of period. Okay, so what is defined by seasonal variation is that it's a regular rise and fall in the time series that recurs consistently. So recurs meaning repeat, recursive rule, right? So that's why you have regular rise and fall in the time series that repeats consistently. So there is a similar pattern of regular peaks and troughs when you try to look at the graph. Okay, so what is a peak and what is a trough? So let me try to give you a simple example. So if let's say I have this kind of data, maybe started from this, then go down, okay, then go up again, okay. All right, so the highest point that you have for the graph is known as the peak. So the lowest point that you have is called as a trough. Okay, so meaning that there's regular rise and also fall. Your higher point and your lower point should be roughly the same as well. So you can see like the pattern moving on. Okay, so for example, in what kind of data you will be able to observe this seasonal variation is that, for example, the first one, if we talk about the sales of an ice cream. So if you want to compare it between whether it's a summertime, it's a springtime, autumn or winter, then obviously the sales of an ice cream is going to be higher when it's in summer. You get what I mean, right? Then, for example, if you are trying to comparing monthly, then you will realize that the number of tourists in the tourist spot is going to be normally higher during the school holiday. Okay, so let's try to look at this example, then we try to find out what is the seasonal variation here. Okay, so by now I'm not sure that whether you can observe or not. Basically, you can see like the different cycle in this graph. So I'll try to use different color to indicate the different cycle here. Okay, so we have the first one. So you'll realize that this is like one, then the other one, then you have the other one and the other one. So 1 period, 2 period, 3 period, and 4 period made up one cycle. Then you'll realize that this pattern recurs again. So this pattern repeats again. Like you can see 1, 2, 3, 4, which is the same pattern, increase a lot, decrease a lot, then after that increase a bit, decrease a bit. So same thing, increase a lot, decrease a lot, increase a bit, then decrease a bit. Okay, then after that when you continue again, then you'll realize that it's the same thing. 2, 3, 4. So when you move on as well, then we have 1, 2, 3, 4. Okay, so you'll realize that 4 point give you one pattern, 4 point give you another similar pattern, then this graph actually recurs continuously. So how can we describe further for this kind of seasonal variation? So you can try to write down how many points made up one cycle. So in this case, it's basically a 4-point cycle. Or the other way to describe it is we can try to use the words period. So 4 periods give you one cycle, right? So which means that there are 4 periods in a cycle. Alright, so that's basically how can you identify it. So the other thing that, okay, yeah, you can try to look at this example, right? So when we talk about the sales of ice cream, yeah, so which means that if let's say we talk about this is spring, summer, then autumn, winter, of course, this is not, a very accurate one because normally the winter will be the lowest one, right? But you can imagine, meaning that if I were to graph the sales of an ice cream on a time series plot, then which means that the peaks here will normally be the summertime lah. So when you plot it, then you realize that every year the summer will be having the highest number of sales. Then for the following year is the second summer that you have in the next year, then continuously. Okay, so for this graph, you'll realize that that's only seasonal variation. There's actually no much change when you try to look at the trend. Because if let's say I were to try to look at it like this, then you'll realize that it actually gives me quite a constant number. So it's just that this seasonal, this pattern of the season keep on repeat for every year. So in terms of the average for the sales of the data, it actually doesn't change much. You can't see actually that's increased a lot or that's decreased in the long term lah. Basically, it keeps like constant. Okay. So now let's try to look at example 1 that we try to identify the trend or the seasonality of these two time series data here. Example 1, identifying the trend and the seasonality of the time series data here. Okay, so from this graph, so first thing, let's try to identify whether there's a trend or not. Okay, so you can see if let's say we try to look at it as a long term, you'll realize that this data point is actually increasing. Am I right? So that's why for A, then it's having an increasing trend. So now let's try to identify the seasonality. So whether there's a variation in terms of their season or not. Okay, so same thing, you will realize that 1, 2, 3, 4, 5. Then after that repeats again 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. So if you are using a different color, then which means 1, 2, 3, 4, 5 made up one cycle. Then after that, the other cycle repeats again. 1, 2, 3, 4, 5, and after that, the last one. Okay, so in this case, then which means that you are having a 5-point cycle. Alright, so it's having a seasonal variation lah, basically. Okay, so for B, then you can see that in general, in long term, then this thing is actually decreasing. So that's why you have a decreasing trend. So how about the seasonal variation here? Is it occurs here? Yes. Okay, so you can also realize that in this case, then what's the seasonal effect that you can see? So it's going to be 1, 2, 3 made up 1, right? Then after that repeats again. So going down, then after that 1, 2, 3 again. Okay, so which roughly the same, then decrease, roughly the same, then decrease. Then after that, same thing repeats again here. 1, 2, and then decrease. Okay, and so on. Then you can realize the next thing, it should be, you can start to predict lah. If let's say something like this, then it should be like this, then after that go down, right? So you can roughly get the pattern here. So this is basically a seasonal variation. So in this case, you are having like 3 points. So that's why it's a 3-point cycle. Okay, so I hope that is direct. It's important for you to know because you are going to use this prior knowledge when we move on, when we talk about smoothing the data in future. Okay, so now let's look at the part for irregular fluctuation. So yeah, the thing that you need to know is how to identify only. Okay, so let's move on for the third part. Alright, so the third aspect, we are going to talk about a cyclic pattern. So basically, just to remind you again, so like what I said, aspect 1 and 2 is much more important because that's the thing that we can do further analysis. So for our syllabus, if let's say the data is irregular, then which means that you can't actually continue with any analysis. So that's why you'll realize that in most of the question, or basically 100% of your question, will be a seasonal index, will be a seasonal data rather than cyclic or irregular. So it's good enough that you know how to identify and you know, how is this shape look like. That's good enough already. Okay. So for cyclic pattern, data exhibit a fluctuation with repetitive nature. Okay. So there is a significant peaks and troughs as well, but then it occurs as an irregular interval. And normally the troughs and the peaks that you have here, right, there is a variation in their amplitude. So which means in their size, like how much you increase, how much you decrease. Okay, so for cyclic pattern, right, normally you'll have this kind of data. Let's say we talk about like earthquake, sometimes it's very hard for you to predict the time and so on, but you know that from time to time it happens. So you can try to see this is that it can increase, decrease, increase, decrease, increase, decrease, and so on. But then the amplitude that it increased, like this one increased this much, then this one only increased this much. And then you realize that the interval also different. So you can see that from here to here, maybe it's like a shorter period. Then from here to here, it's like a longer period. You get what I mean? So that's why you still can see like it's a cycle of increase, decrease, increase, decrease. But then it actually is irregular. So this is known as cyclic pattern. And basically, we don't really have this kind of data in the syllabus that we are going to do. Okay, so the last one here, same thing. We can't do any analysis as well if you got this kind of data. So that's why in your exam, normally you don't have this thing. So irregular variation reflects the unpredictability common in all the statistical data. So for irregular variation, it do not follow a particular model. It's basically show random fluctuations. So you can see here, up, down, up, down, up, down, then suddenly here you have up, then down, down. So basically you can't see any pattern here. So this is like irregular. You can't actually predict anything out of it. You get what I mean, right? So which means, for example, for cyclic, you also can't predict, is that going to be, should I draw like this or should I just continue like this? You get what I mean, right? So for irregular, it's even harder. You doesn't really know it should be up, down, or what. So maybe it can be something like this. It can even go down. We doesn't know what happened next. So for these two, it's like unpredictable. So that's why we can't do any further analysis basically. Okay. So now let's look at example 2. Then now for each of the following, we need to identify the components here. For each of the following, identify which of the components listed is most likely to apply. Okay, so we have increasing trend, decreasing trend, seasonal variation, cyclic variation, and irregular variation. So you just try to find out the one that most likely to apply. It will be case to case different, but then we are just going to write down, try to use our best logic to try to write down the components that will be suitable for each of the situation. Okay, so the first one, we have the average monthly maximum temperature in Melbourne. Okay, so you know that Melbourne is a city which you have 4 seasons, am I right? So that's why when you try to look at the monthly temperature, it will be roughly the same when you repeat like annually. So for example, when we talk about temperature in January this year, it will be roughly the same with next year. Then if you try to compare like the temperature during the winter season, then it's going to be the same with the winter season next year also. Okay, so the first one that obviously we can try to do is the seasonal variation. Okay. Second thing, if you try to think further, right, you'll realize that if we talk about we have this global warming effect to in our Earth now, then you know that if we are trying to observe the temperature in terms of long run, then you'll be able to realize that the temperature over the year will actually become higher and higher because of this effect. So that's why in long term, it will give you an increasing trend as well. Okay, so no, don't worry about this part whether you can think of whether trend applies or not, because in the real exam, normally you will be given a set of data that you try to analyze from that. You won't be giving like the situation and the question asks you to guess lah, basically. Okay, so this is just for your understanding only. Okay, so two, so we have the value of a car over the year. So I think this one is actually quite simple. So you can just imagine that if you buy a car, then after that, how is the value of the car if you continue to keep it over the year? Then obviously the price of the car will be going down lower and lower over the years, right? So that's why it will be a decreasing trend. And basically you do not have like seasonal or cyclic or irregular lah. Basically it's keep on going down only. Okay, then the third one, the daily distance covered by a taxi driver in Sydney over a certain period. Okay, so for this one, then we also can't say it's increasing or decreases. Basically, it's going to be fluctuated around. But then you can argue it's either seasonal, maybe like weekend more people, weekday lesser people, or it's cyclic, or it's like irregular, which you can't see a pattern. So in this case, maybe it will be C, maybe it will be D, maybe it will be E. So depends on the situation. All right. Then four, the monthly sales data for umbrella over the year. Okay. So in this case, you can try to imagine that if let's say in a such a year that maybe umbrella is so highest during the raining season, then in this case, then it will most likely follow a seasonal variation as well. But of course, by looking at the situation, it can be cyclic or irregular as well. But we are just writing down the one that we think that's the most suitable. Okay. So five, the living cost measure over the year. Okay. So I think this one is actually quite direct also. We have this inflation. So uh, think of it logically, then you know that the living cost over the year will be keep on increasing when you try to look at it in a long term. Okay, so the last one, the number of daily births in a particular country hospital over a period of 10 days. So this one we also doesn't know. So normally it won't be season lah. I mean, you won't be like any season where more people are born than for the season where less people are born. So maybe you have a certain pattern, we're not sure, or most likely it will be a irregular one. Okay, so I think for this one, I can just write down irregular lah. I think that's much more logic. All right, so that's a part for example two. So I hope that from here you are able to get an idea what is that meant. So now we go back to our example three and we try to interpret the graph that we have just now. All right, example three. So now by looking at this graph, can you use what you have just learned so to describe this graph? Okay, so let's try to check the trend first. So you can see that for this one, you can obviously realize that there's an increasing trend when we try to observe it in terms of long run. Am I right? So I hope that you can actually get the first one, which is you have a long-term increasing trend. Okay, so second thing, do you realize that there is any pattern in terms of the graph here, in terms of the data point here? So yeah, actually you can see that's like you can realize by looking at the higher point and also the lower point, you'll realize that it's like a U here, a U here, and another U here. Then obviously it is something that give you a certain pattern. Okay, so if you want to look at it in a easier way, then you can try to see. So this one same thing. 1, 2, 3. So you realize that you can't plot this, right? Because 1, 2, 3, 4, then 1, 2, 3, then when you do 4 here, then it's going to give you another different cycle already. So that's why 1, 2, 3, then repeat 1, 2, 3, then repeat 1, 2, 3. So that's why in this case, it should be like this. Okay, then after that, repeat the cycle again. So you can see going up, then after that down a lot, then going up a little bit. So you can imagine that if you were to repeat that in future, then it's most likely going to look like this, which you have up. Okay, then what can you imagine for the next point is going to be going down. Am I right? Then after that, after you're going down, then it's going to going up a little bit. Then after that, going up a lot as well. So you can try to actually imagine what is going to happen in the future. So this is what is then meant by seasonal variation. And by looking at this pattern, by looking at their trend, then you'll be able to, guess what is going to happen in the future. Okay, so in this case, you have a long-term increasing trend, then seasonal pattern, you are going to have like, is a 3-point cycle. Okay, so it's having a seasonal variation lah, basically. Alright, so I hope that you can look at it now. So before we end this lesson, I'm going to talk about a bit of overview, like how bivariate data analysis and time series data are connecting to each other. Then I'm going to use this example to explain to you why do we need like further steps or further approach when we try to deal with time series data as well. Alright, so I hope that you can take some time to understand what I try to speak here. So it will be easier for you when you move on to the further lectures in future. Okay, so in topic 3.1, when we talk about bivariate data analysis, right, then which means that you will be given a set of raw data, which you have like, let's talk about numerical data only, okay? So you have a set of raw data which you have two variables. Then from there, we try to do analysis. We find out the strength, the direction, the linear, whether it's linear or not, and so on. Then we try to carry out like the numerical measure. Then from there, we are trying to look at what is a trend. So what's the direction? So by looking at the trend, then we can fit in what we call as the linear regression model. Am I right? So by doing this, what do we want to get out of it is basically for the equation for the linear regression model, then we try to do prediction. So this is like the whole process, like how we carry out bivariate data analysis for a set of numerical data. Okay, so for time series data, you imagine that it's actually the same thing when we talk about numerical data, but then the data that we are going to deal with, right, isn't that easy that is going to give you the trend only. Okay, let me try to give you a simple example here. You see, there's one part here, we talk about the value of the car, right? So you imagine that if let's say I'm going to plot the value of a car over the year, then what is the type of graph that I'm going to have is basically just depending on how much it reduced for each year. So maybe it can sometimes going down a lot, sometimes a bit, but in general case, then you can see that the value of the car obviously will keep on going down. You wouldn't be able to get anything like going up. You get what I mean, right? So in this case, there is no seasonal effect that take place, which means that you do not have any seasonal variation. Then yes, obviously you can, what you need to do is just carry out what we have done for bivariate data analysis, which is to feed the data into a linear regression model. Then after that, by using your y equals mx plus c, you are going to get a best fit line. Then you will be able to predict what is the price of the car over the year. Okay, but now what is the problem here that we are going to encounter for this chapter is that the data that we are going to have is most likely going to be the data with seasonal variation, which means in this case. Okay, so what is the problem here is that you see, I can roughly guess that what happened in the future, am I right? But then I wouldn't be able to actually give you 100% correct one, which means I'm not sure whether this is going to reduce how much. If let's say I try to draw like this, I'm still going up, I'm still going here. I think it still follow this trend, am I right? So how should I decide which one is the best one for me to draw? You get what I mean? I still follow this pattern, but then I wouldn't be able to know how much I should increase, how much I should decrease, and so on. So it will actually give me a very difficult situation when I want to use a linear model, a linear regression model, which is y equals mx plus c, so to help me to get the prediction. So that's why, what do we need to do in this time series data? We have something special here, which is known as smoothing the data. Okay, so for this part, we are going to deal with most likely seasonal data. So which means that is the data which you have periods in cycle. Okay, like what we have just now, for example, this one. All right. So what do we need to do so that we can try to find out what is the underlying trend? So which means that the trend that which seems not so obvious by looking at this graph. So there are two methods that we need to learn, which is called as smoothing the data. Okay, smoothing the data. Alright, so in the future lesson, we are going to learn about these two things. So the first one is known as moving average. The second one is called as deseasonalization. So now you only need to imagine that what happened after we carry out these two approach is that we are going to get a graph that is going to be nearer, closer to each other so that we can try to find out a much more accurate linear regression model. So it's, okay, I mean, let me try to give you a simple example here. If you are going to find out what is the, let's talk about global warming lah. Okay, if you are talking about global warming, right, then we should know that the temperature for the Earth is actually increasing over the year. Am I right? But then if I am investigating the temperature of a country which you have 4 seasons, you'll realize that the graph wouldn't give you something like it's increasing over the year. You get what I mean, right? Because you have 4 seasons. You can't compare the temperature of summer and winter in the same page. You get what I mean? So the graph that you are having is basically having something like this maybe. Yeah. So maybe for spring, you get a lower one, then the summer, you have the highest, then autumn, then winter. But then it's going to repeat again. Okay, so you realize that every time summer is something like this give you one cycle, then the other cycle. In terms of long run, it will give you an increasing trend. But then I can't compare everything in one page because of I have seasonal effect, which is the effect due to the season, but not the effect due to the global warming. You get what I mean? For example, you see from this part to this part, I can see that's increase. But is this effect of global warming? No, it's actually the effect of this is the spring season, then this is the summer season. Then of course the temperature will increase. So that's why for me to find out what is the underlying trend, what is the trend that is not so obvious that is caused by this global warming, I will need to remove all this seasonal effect that caused by autumn, winter, and so on. Or in the other case, maybe we can talk about quarter or months. So we try to remove all this seasonal effect from the data. Then from there, we'll be able to look at the trend. Then we can proceed to smooth the data. And then from the data that we smooth it, then we try to do prediction. Okay, then for the prediction, it's going to be a little bit troublesome as well, because you imagine that for the underlying trend, maybe it gives you an increasing one. For example, for this one, after I try to smooth the data, then maybe I get something. You doesn't really need to draw together with me. I hope that you just can listen and understand it. Okay, so by looking at this increasing trend, then at the end, maybe I'll be able to get this linear model as if this straight line. Okay, but then you can imagine that if I were to predict what is the number of visitor that happen here, I wouldn't actually predict here, because I know that for May to August, for this season, normally is going to be lower than my average, if you realize that, right? Okay, so that's why when I try to do my prediction, I need to indicate, I need to take into the consideration for what is going to happen for that particular season as well. So when we are trying to do the prediction here, then we need to take into the consideration, we need to factor in the seasonal effect. So that's why you'll realize that the thing that you are going to do is going to be much more troublesome, is going to be much more you have a lot of steps that you need to do before you can fit in the linear regression model, which is by these two approach. We are going to learn it starting from next lesson. Okay, so I hope that you can understand what do we mean here. So if let's say you got any question, then you can feel free to ask me personally. So there's no homework for today's lesson because basically it's just about graph and you know how to construct it, you know how to find out the trend and how to interpret the cycle, the seasonality thing. So take this time to understand everything that I try to speak here, then it will be helpful for you when we move on to for the next class. All right, so yeah, have a good break of your no homework weekend as well. So for next week, we are going to continue. You are going to have homework again. So after you finish this, then you just upload the handout or the notes that you have, and that will serve as your attendance. All right, so thanks everyone for watching. So I'll see you next week.